Am I audible now? Yeah, participants. Okay. So in the previous class, we have learned many concepts related to embedded systems, IoT, and architecture of IoT, and architecture of microcontrollers, and the basic boards which we have used in our embedded systems and IoT, like Arduino Uno, ESP8266 node MCU, and the high-level Raspberry Pi board. So the installation process of Raspberry Pi board is, so we have to take an SD card, we have to insert this SD card in the laptop, and we have to open an application Raspberry Pi imager. So this image will choose the Raspberry Pi device. So which Raspberry Pi board you want to program, like Raspberry Pi 4 and Raspberry Pi 5. Raspberry Pi 4 has 2 GB of RAM, and the little higher version of Raspberry Pi is 5, which has 4 GB of RAM. Okay. Next, we are choosing the recommended OS, that is Raspbian OS. Next is we are choosing the device or the SD card, which we are willing like to boot the OS. Next is edit settings. We are setting the machine name or the host name or the user login credentials and enabling internet and other SSH service and terminal services. And next, we are going to boot the device. Once the booting is happened, okay, SD card is loaded with operating system. Remove the SD card from the laptop, disconnect it, and insert the SD card on the backside panel of the SD card slot of Raspberry Pi board. And power up the Raspberry Pi board. This will boot Raspbian OS, similar like our Ubuntu Linux OS. Once you log in, okay, we have a test like blinking LED using Raspberry Pi board. So connecting the Raspberry Pi board with LED interface is the GPIO interface. We are using GPIO interface for blinking an LED, positive terminal to the resistor and GPIO, and the negative terminal to the ground pin. So once you download the program Raspberry Pi, okay, you run it in the terminal like interactive mode or command line mode or IDE mode. Any kind of mode you can run the Python script. Once you run the Python script, okay, LED program will run. It will blink continuously with a given amount of delay in the program. Next is Raspberry Pi interfacing with DS18B20 temperature sensor. So the temperature sensor is a digital temperature sensor. Usually, the sensors which are available in the market are of analog type. Okay, so to interface the sensors to the digital microprocessor or microcontroller, we use the interface called analog to digital converter circuit. So instead of using this analog to digital converter circuit, we have a direct interface with DS18B20 temperature sensor. So DS18B20 temperature sensor is a three-terminal device which has VCC, ground, data pins. So data pin is connected to the GPIO interface. VCC and ground are connected to red and blue wires of the GPIO pins. So to display these values, okay, we are using a 16 cross 2 LCD. 16 cross 2 LCD is connected in 4-bit mode here. Okay, white, ash, purple, blue are the 4-bit lines of data. Okay. This data we are displaying in degree Celsius and degree Fahrenheit. Next is introduction to Python. So as a top level, we have learned to program embedded microcontrollers and microprocessors using C language, embedded C language. Okay. Similarly, to program Raspberry Pi, so to program Raspberry Pi board, we use Python programming. Python programming, the contents are introduction to Python, about Python, history of Python, Python features, industry applications of Python, Linux commands, okay, running Python scripts using Linux and Windows data types. So Python is a high-level interpreted, interactive, and object-oriented scripting language. Okay, Python was designed to be a highly readable, which uses English keywords frequently, whereas other languages use punctuations and it has fewer syntactical constructs and than other languages. So Python is a high-level scripting language. So usually there are scripting languages like C#, TCL, Bash, Python, Perl. All these are scripting languages. So the scripting languages are developed based on Linux programming. So using the scripting languages, we use to write the interfaces of Raspberry Pi with LED, sensors, actuators. Okay. So Python follows as a constructs of interpreter programming language. Next is Python is open source. It is portable and is powerful. Open source is nothing but it is freely available to download, install, and run the programs. Next is it is portable. Portable means it is easy to learn and we can easily install the application. We can write the code and check the syntax and run the code also easily. It is powerful because we built many amount of applications using Python scripting language. Next is history of Python. Python was developed, okay, in the late 18th and 19th from the Mathematical Research Institute of Netherlands. Python is derived from many of the other programming languages like ABC, Modular 3, C, C++, Algo 68, Smalltalk. So all these are Unix shell scripting languages and some are high-level programming languages. So using these programming languages, we have developed other programming languages, Python, by these research institutes in Netherlands. Okay, Python features, easy to learn, easy to read, easy to maintain. Interactive modes, portable, database. You can build commercial databases also using Python programming language. Next is extendable. So Python can be extendable to any number of tools by interfaces. So we can write a Python code and call C function also. We can write a Python code and we can call Java. There is interoperability between Python and other programming languages. GUI programming. So most of the GUI applications we develop using C# or CSS Java. Okay, but using Python also we can develop GUI based programming. Scalable. So scalable means we write a script, we write a program using Java and Python, but The better constructs and better supports are available for Python than other programming languages. That is what the scalability is. Industry applications. So in industry, most of the current industries, traditionally they used to follow HTML, CSS, Java, PHP for the development of web applications. Nowadays, they are using Python. Okay, ad hoc programming. So learning wise, research wise, ad hoc programming, Python is mainly used. And steering scientific applications. So we have many applications for scientific uses. Like example, we want to use Schrodinger wave equations. So Schrodinger wave equation tools also can run using Python. Extension language. So Python has extensions to all the programming languages and all the shell scripting languages. Like Python can be used for Java, Python can be used for C, Python can be used in other C shell programming language. Okay. Next is database applications. So MySQL, Oracle, like this similar, Python can also be used for programming database. Geo applications, I have told you, Geo applications. So earlier, Geo application mostly they used to develop using Java, .NET, and frameworks. Now Python can also be used for the development of Geo applications. Educations, it is like learning and research. Any question, Sama? Who are the top leading industry persons? Those who are using Python for several activities. Google, NASA, Industrial Light and Magic, Yahoo, Real Networks, Red Hat, Linux tools. So Linux and its commands. So Linux is the basic platform and Linux is the operating system which is developed. Okay. So Linux has two components, shell and kernel. So shell is used for the programming language and kernel is used to run the operating system. So shell and kernel are separate in the Linux. So whatever the commands we write are executing on the shell. So this is Linux commands. ls is used for list the files and folders of the directory. cd is used to change the directory. mkdir is used for creating a new directory. cp is used for copy the files or the contents from the one destination to another location. mv is used to move the files or folders. pwd is reflecting to current working directory. rm is used for remove the files. rm -i prompts for the delete for the interactive mode. So rm -i the file name. If you want to delete the file, you have to press yes. Else no. That is what the interactive mode is. rm -rf is recursively if you have any subfolders or subfiles in any main directory, all the files and folders gets deleted using rm -rf. So this is very powerful tool. rmdir to remove the empty directory. Next is file permissions. chmod is used to give the permissions. So basically the permissions are like this: user, group, and others. So user will have full permissions, group will have read and execute permissions, others will have read only permissions, or else if you want to give, you can give read and execute permissions also. The same way, ch group. To change the permissions of the group, we use ch group. Ch own to change the permissions of the owner. So I have a file, file1.txt. I have to change the permissions for the owner. So what command I use? Ch own. Clear? Next is date. Date is simple command which will display the date and time of the current. chsh. So this will change the user login shell. So we have different amounts of shell like bash shell, C shell, TCL shell, KSH shell, and Perl shell. So all these are shells. So using the CSH the user can change the login shell also. Next is password. Password is a command used to set the password for an user. PS is used to report the process. So what we do in our laptop, Control Alt Delete will place to go for the task manager. But we will do PS stop for checking the process or the jobs which are running in the computer using Linux commands. Kill is used to terminate. What we will do in command in our task manager, we will select using the GUI mouse and click on the end task. Next is user commands. Who am I? Who am I? So all these are replicating the same amount of output, which will display the users logged in with their respective date and time and active users in the Linux operating system. Disk space commands. So disk space commands are du minus sh, df-h, df-kh, df-th, and free. Free will give you the RAM space and swap space. And df, du, dh, everything will give you the disk space, hard disk. Okay, right. Next is fgrep. Commands in file systems. Fgrep is used to search the exact string in the text files. Find is used to find the files in the drive or folder system. Locate is used to command which finds the files or folders using very fast algorithm. Yes, someone is speaking. So yeah, someone mic is enabled, I think. We'll proceed further. Any questions? Okay. So commands for showing the file details. So we have some file, WordPad, Notepad. Okay. So WC is the command used to check the number of characters in the file. Sort is used for sorting the lines, print the lines in a very sorting order. Next is unique, used to print the files by removing duplicate adjacent lines. Touch is used to create an empty file. CMP is used to compare the files. Diff is used to compare two files for differences. Running a Python. So we have written a Python program. Okay. Print hello world. Okay. So we have three methods: interactive interpreter, okay, script based, and integrated development environment. So all these three methods can be used for running a Python program. So integrated development environment is used for Windows operating systems, and command line, script, interactive interpreter, okay, interpreter. These two modes are used in Linux. Next, coming to data types. So Python has similar data types like C programming or other programming languages has numbers, string, list, tuple, dictionary. So list, tuple, dictionary are similar to arrays in our C programming. So types of operators. We have some operators like arithmetic operators, comparison operators, bitwise operators, logical operators, membership operators, identity operators. Okay. So using numbers as a database, we operate addition, subtraction, multiplication, division. Okay. And doing the logical operations also using numbers. So we have another operator or the data type, which is similar like int, long integer, float, and complex numbers also. Complex numbers is nothing but 3i plus j, 9j plus 3k, similar. Complex numbers. So string is another kind of data type, which is a group of characters, which is represented in single quotes, double quotes. So here is an example. str equal to hello world. Print string will print the complete string. Print string of 0th character, it will print only H. 2 down to 5 will print the 2 to 5 characters. 2 down to 0 will print the 2 index position 2 to the last characters. Print string 2 times. That is multiplication. Next, string plus test. So it will concatenate hello world test. List and tuples. List and tuples are the two different types of data types used in Python programming language, which are similar to arrays in our C programming. So list is identified by using square brackets and tuples are identified by using small brackets. So list is a array of dissimilar data types. So we have characters, numbers, float, integers, and all types of things in list. In tuple also we have dissimilar data types, but those are represented in small brackets. Dictionary is another kind of data type which has key value pair. So this is key and this is the value. This is the key, this is the value. This is the key, this is the value. So we have to represent or type or detect the values of dictionary using key value pairing method. Next, coming deep down to the Python programming, we have decision making, okay, loops, IO functions. Decision making we use if expression is true, it will execute the statements under it. If false, it will give the return type 0. If else is another construct of decision making. If the expression is true, it will execute the statements, else it will execute the else block statements. Nested if. Nested if is nothing but continuously we will have multiple elif. Next is looping statements. So why we use the looping statements? To repeat a task continuously for certain amount of time or infinity number of times, we use the looping statements. One among the basic looping statement is while. While of expression is true, then it will execute the statements. Next is infinity loop is an other kind of loop setup. Using any kind of looping statement we can use. Conditional statements. So conditional statements we have if else, and nested if. Okay. So if the expression is true, it will execute the statements. If the expression is false, it will return 0 value. The return type of if is expressions and boolean. Next is if else. If the statement is true, expression is true, sorry, the statements will execute. If expression is false, else block will get executed. Nested if. Nested if is a combination of if, elif, and else. If condition 1 is true, it will execute statement 1. If condition 1 is false, it will execute condition 2. If condition 2 is false, it execute condition 3. If condition 3 is false, it execute statement 4 directly, else. So this is nested if. Clear, Sweta? Sweta, you have got it the point? Yes, sir. So infinity loop. So infinity loop is nothing but while expression. Expression is always true. Okay. Then it is infinity loop. So using else statement with loops. While count is less than 5. Okay. So we are printing the values 5 down to 1. Next is for loop. For loop as expression or sequence of expressions and statements. If for loop, the iterating where is in sequence is true, then it will execute the statements, else it will report, else block, or any other statements under it. In the example, for letter in Blackbucks, print letter. For letter in Blackbucks, print letter. So what it will print? Black bucks. Every character it will print unless until all the characters gets printed, and then there are no characters more, it will go to print error, black box error. Next is nested loops. So similarly, we have nested if statements like conditions. We have nested loops too. So in nested loops, we can incorporate for loop, while loop, or while loop for loop also, or for loop in the for loop and while loop in the while loop also. This is the syntax how it looks like. For expression, okay, if the expression is true, it has to execute another for loop, and it comes to the other statements of the block. Next is while syntax. While expression is true, it will come for the immediate while expression. Then it will execute the statements. And based on the top priority assignment we have given in the coursework, okay, loop control statements. Write a program using the loop control statements for Python script. So there are mainly 3 loop control statements: break, continue, and pass. Break will break the loop at any instance of time once the break command is executed. Okay, and continue will continue even after the looping statements have to run. Next is pass. So if you want to pass the condition valid at that instance of time, then we use pass statement. So break will break here itself, and it will till print till h in the first example. Next is even after calling the continue, it will print python, Python it will print completely. Here what it will print? If letter equal to h, HON it will print here. Coming to the next topic in Python file IOs. So all those examples are in the slides. You can practice them. Okay, already they are executed for you in the detailed classroom. So as this is the fresh wind up class, on the fast pace, we are going it, skipping it, and just understanding what are the examples we have learned, just to brief you. Okay, next is Python file IOs. So what are file IOs? We have file systems which we work with: file open, file create, file read, file write, file execute. All these things we operate on the file systems. So those are file IOs. So to do these kind of activities, we have read mode, read binary format, read and write for binary format, write only binary format, write and read both. Okay, these are all of the different modes we have to use for file IOs. Also, we have appending binary mode also. So here is the syntax how we create a or open a, close a file object. So file object is nothing but file name equal to open file name, which is the access mode, read mode, write mode, read binary, write binary, whatever it is, or append the data. So here is an example. Okay, so FO is the file object. I'm opening the python.txt file in the write mode. What I am writing? Name of the file, close or not, opening. So all these texts are written to the file python.txt. Next is close method. File object.close is the syntax to be used to close any file. So here is an example of file close method. We have opened a file for write mode and f4.close is used to close the file method. Next is read method, write method, sorry. File object dot write. So whatever the string we want to write or put that text into that python.txt. So f4.write, this Python is a great language, new line. Yeah, it's great. So these sentences are added to python.txt in the write mode and it will close the file after writing those text to that file. Next is read method. So we want to read, we are opening a file foo.txt in read mode. Okay, what we are reading, first 10 characters of the file and we are closing the file. Next is file positions. So we have a file, we have a cursor. Okay, so here is my cursor example. Okay, it is in 1, 2, 3, 4, 5th line, end position. So tell offset and other command is seek, I think. Seek, sorry. Tell, seek, offset. These are the 3 file position commands used in Python to notify us where is the cursor in the file. This is the main important object of file positions. So directories in Python. So using the file object methods, okay, we have manipulated the operations on the files. Next, using OS object methods, we will work on OS methods for executing the operations of the files. Next, OS rename. So if you want to rename a file, what we will do in the Windows, we'll just right click, go to rename directly. But you don't have any GUI, you don't have any Linux, you have only the command line. Using Python, you can do in this way. Okay. OS rename is the method. It is object directive. So it will rename the file, current file name to new file. text1.txt to text2.txt. Next, if you want to delete the file, that is remove the file. If you want to create a new directory, if you want to change the directory, if you want to get the current working directory, using Python OS methods, os.remove, os.incdir, os.chbar, os.getCWR. So all these methods are used to get the OS based directories. Next is Python functions. Similarly, like C programming, we have Python functions also. So we have functions, definition, calling function, and return type. So definition of the function, we are passing some parameters, function name, function statements, and return expression. Okay. So this is the syntax. So example, okay, def change That is my list. So to the existing list, I am appending my list, append 1, 2, 3, 4. So where is my list function? My list variable parameter, it is in the calling function. So what it has to do? Change my list. So what will append? 10, 20, 30, comma 1, comma 2, comma 3, comma 4 will happen as the output. If you print the values of my list. So what is the return type? My list is the return. So what is the data type we are using here? List. The same way we are getting the return type. If you are using array, array will get the output. If you are using dictionary, dictionary has to get the output. If you are using numbers, numbers has to get the output. Whatever the data type is, the return type replicates. Clear so far, everyone? Someone please reply whether you are able to see the screen. My voice is clear, audible. Dear participants, you are in the class. Ashrita, first time I am seeing this name. Yeah, Blackbucks. Thank you, Kavya. I hope the pace is very fast, even though this is a review session. So in detail, we have learned all these codes executing in command line interface by writing a script. Next is return statement. So the very important part of function is return type. So here we are passing two arguments. Okay, those arguments will replicate to the sum. That is total. So whatever the value we get the total at the runtime, we are passing two values to the arguments 1, arg1 and arg2. If the values are 3 and 4, the total is 5. Then we'll get the return type as total. That is also a value. That is number. Return. Next is global versus local. So the statements which are declared or the values which are declared or the variables which are declared outside the definition of a function are global variables. Within the function, if we declare, those are local variables. So total equal to 0 is a global variable. So initially what it will return? So in the last statement, print outside, okay, total what it will print? It will print 0. Even though return is total, okay. So this is global declaration. So it will return total equal to 0, which is total. Clear? Next is IoT cloud computing. So what is cloud computing? Cloud computing is an array of network computers that allow you to offload process tasks or storage from your embedded systems. As we have discussed personally, as a project perspective, okay. So as a part of project, we have done a water quality management system. So using this water quality management system, we have connected for a 1 acre of pond, okay, 4 devices. These 4 devices are connected in a network. So all these are offloaded one on one each other. And these all the 4 Raspberry Pi nodes are connected to a AWS cloud. So all the data is received using internet on the AWS cloud. So this is how the application of IoT cloud computing works. Now whatever the class we are learning, okay. So you are sitting somewhere, I am teaching you using my laptop and you are listening to the lecture, okay. And Blackbucks team is recording this session and the data is directly recording in the storage of the cloud in Zoom. This is one of the real-time applications. So similarly, we'll deep dive into understand in a recap fast way. IoT cloud. IoT applications will need support from a reliable, fast, and agile computing platforms. Fast and agile means there is a response to the quick, immediate action of the IoT devices. So IoT devices can overcome lack of software from memory, storage, hardware, and other capabilities to compute or store the data. So as the Raspberry Pi 5 Okay. Initially, when we did this project, we have the Raspberry Pi with 512 MB of RAM. Okay. There is the 512 MB RAM and 4 GB RAM nowadays. Okay. Using this 512 MB of RAM, we are unable to compute huge amount of code and process huge amount of data on the RAM. So what we do is we collect all the data, chunk data from the sensor, from the Raspberry Pi board, and we used to transmit or pump the data in the form of CSV format or Excel format to the cloud, and we refine there using algorithms using Python. Okay, and we filter the data and publish the data to the user on their web page and mobile applications directly from the cloud. And there is no sending data back to the Raspberry Pi board. As the resources on the Raspberry Pi board are very less and the storage is also very less. We hardly use 16 GB memory card. Nowadays, the Raspberry Pi boards are compatible up to 256 and 1 TB SD card flash also. And they are supporting external hard disk interface using USB to store 4 TB, 5 TB. But it is very risk to connect external hard disk on the Raspberry Pi board in this environment. Why? Because the power limitations are very high. The sensors require huge amount of power and to collect the data from environment and send it to the Raspberry Pi. If we connect external hard disk, okay, again it takes large amount of power. So to avoid this, we directly send the data to the internet using cloud computing. So there are main three cloud service models: software as a service, platform as a service, infrastructure as a service. Okay, understanding each point. Okay, cloud computing, as we have discussed, several computers, laptops, mobile phones, or electronic gadgets which are connected with internet are clubbed together in a network are called cloud computing. Even your house with many devices connected is a cloud computing. That is infrastructure. Okay. Service models, software application, platform, infrastructure. Service models, infrastructure. So infrastructure is nothing but servers. They have physical servers or physical computers, which are with storage, RAM, CPU. So it is called infrastructure as a service. Next is platform as a service. So platform as a service has operating system like Windows or Linux or Mac OS, any kind of OS, open source. If we have a software as a service, okay, so we need to have infrastructure, we need to have platform, we need to install our application to run the application. So all these models are interlinked. So this is a typical example of cloud computing. So we have an infrastructure, okay, which is running on the compute, storage, and network. And we have a platform as a service. That means we are using database application, database OS like Oracle database OS or Linux operating system or Windows operating system. On this top, we are installing the applications which are related to monitoring or finance or communication, and the end user is accessing using servers, desktops, tablets, phones, and laptops. So characteristics: on-demand self-service. So when you need, then it can be accessed. Broad network access, connectivity options. Anywhere we can connect in this world. Resource pooling. So if you have resources like 16 GB of RAM, okay, and 4 core processor and 1 TB of space. This is the minimum space provided by a cloud vendor like Amazon or AWS, Azure, GCP, or any other private cloud provider. So resource pooling is nothing but you can share your compute resources to another person also. That is how it can be done based on the split method in cloud computing. Next is deployment models: private cloud, public cloud, community cloud, hybrid cloud. So private cloud is nothing but the individual office data centers. Public clouds are nothing but AWS, Azure, GCP. Community clouds means, so we have IBM. IBM has its own cloud. Hybrid clouds. So combining private and public clouds is called hybrid clouds. Someone will have their own data center in the office, and even to take the data backup, okay, when the power will go, when the network will go, they are not dependent on their own infrastructure, then they will go for a hybrid cloud model. We are able to hear me clearly? The slides presentation is visible? Dear participants? Yes, sir. So enabling technologies. So coming back to the 2000s and 1990s. So here is an example. Okay. So for attendance monitoring system in traditional days, they used to use RFID tags in corporate level, not in the school levels or college levels. Okay. In the top universities, they used to use RFID tags. Okay. For faculty, for attendance system. And later after that advancements, we came up with sensors. So face detection, face recognition, or thumb impression, or retina recognition. So using these sensors, we used to enable attendance. Next is smart technology. So if an employee is registered for a shift from 9 a.m. to 6 p.m., okay, so his laptop has a software which will wake him awake for 9 hours of duration. So that is smart technology. Okay, next is nanotech. So whether the employee is in front of the laptop or not. This is a question for a manager. Even the smart tech is there, nanotech. Next, to enable this, the computer camera or the screen time, everything is monitored using nanotech. So this is how the advancements in the technologies has evolved. Clear so far, everyone? Applications. So we have a wide varieties of applications of IoT in education, food, pharma, logistics, retail, and management. So coming to the management, okay, waste management, urban planning, production management, data. Logistics like warehouse, Amazon warehouse, big basket warehouse. Okay, so everything is barcoded and QR coded. Next is retail. In retail, we go for a shopping mall. Okay, for a mall pantaloons, we have a clothing purchases, or we have a gadgets purchases. Everywhere we have a QR code, barcode, or some code to retail sales. Next is pharmaceuticals. So in pharmaceuticals, so not to display the information directly to the user or the end user, so they code it in the form of a QR code or barcode about the drug conductivity and drug dealing, drug combination, and all those things they put in the formula encrypted. So they will use the IoT here. And in the food perspective, calculating the age of a food. So next is Internet of Things, mobile learning, smart objects, virtual worlds, gamification. In the administration, okay, we use school attendance, voting system, media, okay, information management. Smart things timeline. So as the IoT evolved in 2008, and it has come up to a vast global production. Okay. So nowadays we are seeing every device. Every device is IoT. Okay. Initially we used to have a job one. In 2012, we used to have a Fitbit and smart gadgets or applications in Android. Next, after that, we came in 2013. Next, Google Nest Wi-Fi application, Google Glasses, and smart TVs, smart cameras. And in 2014, we got a Apple iWatch. And in 2020s, we have got a personal assistant robots. And nowadays, if we see every device, okay, smart TV, AC and refrigerator and door opening, lights, music system, washing machine, everything are controlled using Wi-Fi network in your personal houses using Alexa, Siri, and mobile apps. Those all are synchronized based on the internet. So this is what called as Internet of Things. So already I have given you practical example. Okay. So me and my partner also both are working for a office. So I do manage my house to check my elder son and younger son. So how they do in the house. And we have Wi-Fi connectivity and we have a 4 device Wi-Fi mesh network. So all over the building we get anywhere the network. And there is a big disaster in the network of 5G and 4G and 3G mobile data. So what we have done, we have enabled in our mobile handsets Wi-Fi calling over network. So this is the advancements in broadband and 5G, 4G network. So whenever there are more call drops, try to enable Wi-Fi calling on your mobile phones. This will enable when your network is not reachable, okay, your call gets connected using Wi-Fi. Okay, this fast the switching is happening. Earlier, when I was childhood, we used to use landline phones. So these phones, to make the switching, we need to plug the socket, plug in a cable to connect to the other state's district lines. Okay. Nowadays, it is happening on the software basis very fast. So every time there are challenges. Okay. So to avoid these challenges, we have to consider them as limitations as the trend is okay, IoT and more growth in technology. So society, people, security, privacy. Next is environmental aspects. So technology can be not be exploited. So hyper cycle of IoT. So how the advancements, how the release of computers or its applications, internets has drastic improvements and saturations. All those are in this graph. A wide variety of 10 to 15 years. Technology roadmap to IoT. So as we have seen, RFID, sensors, and nanotechnology and fiber technology. The future of IoT, we can see completely, it is vast. So IoT landscape, so the companies which are working with IoT and their products. Thank you. So that's all from my side. If you have any questions related to subject, we will continue, or else Blackbucks will handle the session further. If you have any questions. Any suggestions from my side? If you have any career doubts. So as we have discussed as a career object for the young bachelors, yes, with a project related question, Blackbucks team will answer. Okay. So they are the right person. So there's a career perspective. So the people or the students, those who are strong in electronic subjects. Okay. Try to take time. Learn microcontroller boards. The top level microcontroller boards like BeagleBone Black, ARM LPC 216, 2138, 1768, and all these top level boards. And learn Python programming languages, solid C programming languages, C data structures, algorithms. As a fresher, okay, there will be questions related to microcontroller, whatever you have learned in your subject. Okay. And next is electronic components, diodes, capacitors, transistors, or digital ICs, whatever it is. Uh, Next is about interfaces like ADC, UART, SPI, I2C, all these things. So mainly we have all the electronic companies like Qualcomm, Robert Bosch, and NXP, Philips, all the companies of electronics, whatever we are using, both Dell, everywhere we have jobs. We have jobs because semiconductor is the base layer. Okay, using this semiconductor, we are building tools. So the basic embedded engineer, who is the engineer who has the knowledge of all the electronic components to assemble this on the board. Once he assembles these components on the board, they have to develop a firmware code. To develop a firmware code, we have to write device drivers. To write the device drivers, we need to learn Linux programming, C language, and embed C language. And another part, as application engineer in embedded systems, we can go for real-time operating system. We can develop products as an application. Clear? Four companies names are like this: Qualcomm, Broadcom, okay, Intel, AMD, Micron. All these are top leading electronic companies, and we can have the small companies also. Okay, very small companies in Hyderabad, I can say. So that they are developing control systems for metro trains in Japan. They have a project for Japan. Okay, so there is a control systems for metro trains. So for automatic door opens, automatic fire alarms, automatic passenger boarding, and all those things. And ticketing system and all those things, applications there based on the embedded systems. So now in our Hyderabad metro also we have all the devices are embedded systems. The train announcement, escalators, and ticketing system. And next is the tap entrance system, security check. Everything is embedded devices. Those all have electronics. Those all have microprocessor. The heart of the embedded system is microcontroller microprocessor. So whatever the board you learn it completely. Okay. Even in automotives also, we have mechanical, mechatronics. Okay. Even in Hyundai, Kia, Toyota, all these companies have embedded opportunities. So this is my personal experience. I got a job for a Volkswagen in Germany. Okay, once I completed my masters, but I am the only child for my parents. Okay, so they didn't allow me to travel abroad, so I stick that with them. So that is the personal experience. So if you have this kind of uh, enthusiasm, try to expand your skills and jump out of the world every day. You can enhance your skills. Okay, so that's all from my side. Probably I'm ending the session. If you want to take it up forward, you please proceed. Okay. So if you have any questions, please talk to Blackbucks team. They will explain you how to do the assignments, what are the activities, projects, or exams, certifications, all those things. Blackbucks team will do. Okay. Yeah. So as the syllabus is completed, so if you have any questions, please let me know. Students, so I have time for you to engage. If you have any questions, please let me know. Any doubts, you can post. So, Banu Prasad, projects. Yeah, Shravani, the Blackbucks team will answer those questions, assignments, PPT, projects, and all those things. Okay. So, I would suggest you as an academic project in your BTech or MTech or in your education. Okay. So, choose a real-time application. Okay. Try to develop it from the scratch level. So, you are seeing, okay. So, most of the cases in the real life applications. For example, if you want to control all the yeah, if you want to control all the appliances of your house, what will be done as a embedded systems, IoT, and if you want to display a digital notice board for your college. Okay. So every day, what is the schedule for your class? So everything you can automate. So as you are using the Raspberry Pi, okay, that is having automation also. It is Linux. So the automation is not possible in your learned the other two microcontroller ports like and ESP8266. But the automation is possible in the Raspberry Pi as it is having the operating system of Linux. You can write on jobs and you can run as per the schedule. So in every morning, we want to send, okay, per day class schedule to all our classmates. So what we'll do, we will create an Excel sheet. We'll load it as a database, okay, and we'll send an email to all our friends at this kind of time. Is it on that in Raspberry Pi waves? So what it will send? We'll send the schedule to all our classmates. So like this real-time application you can take in your projects for academics and as a part of complex microcontroller boards like ARM. Okay, you need to understand from the 3 months or 6 months of your project. Try to try to be a self learner most of the time. You have to learn on your own by reading the textbooks, articles, internet, online classes, or even YouTube. Okay, so YouTube deflects you from watching the technical videos by its ads to move to the reels. Okay, but try to keep attention on your subject. So this is the most dirty part of our YouTube. So everything is fine with the YouTube. So we can get ARM architecture on the YouTube classes, understand it, learn it, and try to code at least one protocol on ARM board. So that is a major point. So whatever the protocol, so we used to have a protocols and interface subject in our MTech. So what are the protocols and interfaces? So the protocols are nothing but those are thumb rules we have to follow. Interface is nothing but whatever the external component we have to connect to the microcontroller board to establish the communication. So we need to follow this protocol. So I have a GPS, I have a GSM module. I have to interface it to the Raspberry Pi or any kind of microcontroller. So I need to use serial communication. So we have different types of serial communications like UART, USART, I2C, SP. So make an interface. Understand the depth level subject. Okay. So whatever the small task you do, understand it's at the depth level. So it will register it in your mind. So that you will never fail. Your word sounds small, sir. Yeah, Teja. So almost all the class is done. So it is dry mouth. I need to fetch a glass of water. So try to understand. I'll try to speak as much as possible. Okay. Uh, is it clear now, Teja? Teja, you are able to hear me? Yes, sir. So most of the applications like fingerprint, face recognition, all these applications are related to embedded systems. So try to get one module, fingerprint module. Try to get retina scan module. Okay. So interface with the ARM microprocessor or microcontroller. And we have variety of touch applications like resistive touch, capacitive touch. Get a sample touch screen of 5 inches and calibrate the touch screen. Okay. So we have a touch screen calibration. This is a big technique used in mobile phones. Okay. So whenever our display is failed or broken, or when we get a repair of the display, initially the software will take care about display calibration. But whereas you can manually do the display calibration, what operation has to be taken care on the display. If it is a capacitive touch, resistive touch is little bit slow. Okay, capacitive touch is very fast. So there are two types of touch displays: resistive touch and capacitive touch. And if we see automotives like aeroplane, our smart cars, nowadays we have electric cars. Okay. So understand the architecture of a car. What are the sensors involved in this car? What is the dashboard? Understand a case study built out of a small part of this. How this airbags works, how ABS works, automatic brake system, and how fuel monitoring will work, how battery checkup will work. Do you know how battery check will work? Someone? Someone please comment in the chat window as an electronic student. Okay. So we will be getting in the mobile phone, in the laptops, in the desktops, or any electronic gadget we have, which is operated by battery. Okay. We will see the battery percentage. How we are getting these values. As electronic students, you should be answer these questions. We have a current sensor. Okay. So using this sensor, we'll find, calculate mathematical operations. Okay. Based on this, how much watt of power is there in our battery. Okay. So connect a live battery, connect a current sensor, and calculate the amount of power flowing through the battery and allow it to discharge by blinking a light or running a motor. Okay. DC motor. Okay. And next, as an embedded application, you can build a power bank on your own as embedded hardware engineer. Interface batteries, connect batteries to a charging circuit and to a charge source also. And how EV vehicles are working, electric vehicles. And nowadays the EV vehicles are made to a hybrid. When the EV vehicles are running, the battery gets discharged. Okay. And when they are running, we are generating motion. Using this motion, we can charge our batteries. Right? So how we can charge these batteries while it is discharging? Correct? Did anyone strike this question? For these kind of questions, there is a lot of R&D going on in the EV industry. Hyundai, Kia, MG, Suzuki, Toyota, BMW, everywhere, all the EV industries. Research is going on. They are trying to see if we have a Suzuki company, if we have BMW company. So most of the dashboard, okay, those components are built by Robot Bosch. So Robot Bosch gets the ICs, sensors from different companies. They interface, they connect, and they calculate parameters. So how they are calculating our tire pressure? Someone can explain me? In Hyundai, nowadays we have a key feature called tire pressure. How they are monitoring our tire pressure? Without connecting it to the air gauge. Someone can understand it is a practical. It is physics. Are Baba. Just use your skill, use your physics knowledge, how we are calculating the air pressure in our car tires or heavy trucks also. So heavy trucks gets out of control and they get hit to other trucks or they may fall into the valleys also. Most of the accidents happens. So there is no interface. So to check the air, we need to have the air pressure gauge. So unless until we put a pump pipe connection to our valve of the tire, okay. In the running time, how will you get this, Harsha? So on the dashboard, we will get an alert. There is a low pressure in your tire, right side wheel, or else left side wheel, or the back right side wheel, or the back left side wheel. How will you get this alert on the dashboard of your car? Harsha, pressure sensor is external component. We stop the car, we connect the pressure monitor. What sensor will use, Sweta? What sensor will use? Yeah, good. We'll use sensor, correct. What sensor we'll use? So this is the application of electronics engineer in embedded systems, no pressure sensor. So pressure sensor is connected directly physically to the valve of the tire. But we are not connecting any valve. No barometer. Teja, no barometer. We don't have any sensor. We don't have pressure related sensors. Directly there is no tire contact. Without getting the tire contact, how we are going to check the air pressure in our car tires or truck tires? Someone knows the concept who are the car drivers, better they can understand. Wheel alignment. Everyone knows wheel alignment. And there is a sensor called tilt sensor. Tilt. So wheel alignment is nothing but if the two wheels are moving, okay, in the same direction and the same movement, okay, they are balanced. If the wheel has any disturbance in bearings or tire pressure, the tilt sensor will move it onto the one side like a balance. Takeda, what we call taraju. So what we put on the one plate 1 kg, and other side we put 4 tomatoes. What will happen? This goes down and this comes up. The same way, if we have a puncture on our tire, the tilt sensor will detect there is a low pressure in your tire and stop your car. Immediately, if it goes flat tire, ABS will apply to avoid accidents. This is how the smartness has come. This is what automotive embedded application is. Okay, build a prototype of it. Check it for your bike. Okay, I have tested it with my friends when I was in MTech for Maruti Alto using a tilt sensor. But the calibration requires very high using mathematical models. Very high precision tilt sensors we have to use. I can show you the sensor number also. Tilt sensor. So next, this. So using 3-axis accelerometer and gyro sensor. So gyro sensor is also called as tilt sensor. Okay. So this kind of tilt sensors we use. So this tilt sensor will detect, okay, the x-axis, y-axis position of your wheels. We have a surface, okay. We have a wheel, okay. This is our x-axis, and this is our y-axis. And this is our z-axis. Z-axis is respect to body of the car, okay. X-axis is respect to the surface, and y-axis is respect to the wheel position aligned on the bearings. This is our connectivity. This is our another wheel. So assume this car tire is big and this car tire is small. So what will happen? The car gets tilted in this direction. So the displacement in y-axis will help you whether the pressure has gone down, okay, or it has become a flat tire. If it is a flat tire, you will have a precision. Here it has to come the flat tire. So it will calculate the x value. If the tire is displaced, it will calculate the x value. Okay, and it will apply ABS. Hope you are understanding the real-time examples. So do these kind of projects in your academics. So your professors or your universities will appreciate you very well. Accident avoiding systems. How to monitor pressures. So if you have a pressure gauge, you can calculate the pressure. So approximately you will get 90% of the value. not 100%. Okay, 90% is decent. Okay, 100% is okay. Sometimes if you fall the tire in the trench, then the x-axis y-axis position will vary. But even without giving a false alarm, if these two movements are restored with some amount of time, then there is no flat tire option or there is no pressure failure in the tire. So to avoid this false alarm, we are giving the 10% limitation. Anyhow, we have trade-offs between all the concepts. So this is a real life example. So all the EV cars has batteries. Right? So how we will check the battery thing? So this is the IC. Okay. So this IC is used to monitor the battery charge, how much it is available. So these kind of applications we have. So these ICs we have in a better way. Okay. From NXP. I can just check. NXP is the top leading company. Okay. Battery management, energy harvesting system. So see battery sensors. They have developed sensors. So these kind of sensors we can use directly to monitor the health of batteries. So they are using SPI communication. Okay. So most of the EV vehicles, UPS, in inverters. So this is circuit, these ICs are used. So developing these kind of chips is a challenge for ALS engineer and making them applicable in the real-time usage for human life is embedded engineer life. Got it, everyone? This discussion created interested concept for your embedded and IoT systems. Yes, sir. Thank you very much. So, Blackbucks team, I'll end the call class. So you can continue the calls and their project doubts, assignment doubts, and all those things. So think beyond your subject, okay, and try to develop such kind of projects for your academics. So today's topic is review 2 of our IoT embedded systems class level. Right? Thank you all. Good night. There is still the class, okay, from the Blackbox side. If you have any questions, please check with them. Thank you.
You can ask your questions now regarding the assessments and assignments.
Good evening, ma'am.
Good evening.
Ma'am, shall we do the project twice? Or it means can two persons do the same project?
I think projects are like teamwork.
How many members can include the project, ma'am?
About the projects, we will inform further. Don't bother about the projects. We'll provide the description and the code will support you regarding the projects. Okay.
Okay. Okay, ma'am.
Yeah. Next week, you are supposed to do the projects, I think. We'll support you. I mean, provide the code, basic code or structure of the how to uh, uh, sensors, all the stuff.
The last deadline of the project title is 6th, no, ma'am. So can 2% take the same project title?
Yeah, it's an individual choice, right? About the projects.
If some, ma'am, if some other person perform the same project or title name, can we perform the same thing?
Yeah, there are 20 projects, right? I think. So,
Yes, ma'am.
yeah, so many people are there, right? So 20 project limited only, right? You can take.
Okay, ma'am. Thank you, ma'am.
Okay.
Hello, ma'am.
Hello.
Yeah, ma'am. We are actually four members from same college joined this internship.
Okay.
Can we do? Can we all do as a group in this project?
Yeah, actually, you have to choose the project,
Yeah,
right? From the 20.
yeah, yeah,
So, uh, if you two choose the same thing and build it on your own, and you can submit the same, right?
yeah. Okay. We four members can submit the same project.
Yeah, it's your wish to pick the project from the 20. So it's your thing to what you have to choose, what you want to choose. From the 20,
Yeah,
you have like smart dustbin, smart irrigation projects, all the stuff, right?
yeah,
Smart car parking. So, what you have to think is what I can do, what I want to do, what I want to build something, what I can do, or uh, take basic review, some gather information about all those and choose one thing from them.
yeah. Okay. Ma'am, will you provide any documentation regarding these projects?
Yeah, after project deadline or whatever, we'll support you regarding the projects about how to do and all those stuff. Don't worry
Documentation.
about those things, huh?
Will you provide documentation regarding these?
Documentation, yeah, project description and basic project code, like those stuff.
Yeah. Thanks.
Example codes and example things we'll provide. You have to think on your own and you can do on your own
Okay.
creatively or think differently and you can do whatever you want.
Okay.
Okay.
How much time will you for project submission, ma'am?
I think it's 1 week, right? 1 or 2 weeks. They didn't mention you the time of the project submission,
No, they didn't mention. They only mentioned the deadline for choosing the
project
title.
titles. Okay, when the submission 6th.
Yeah, see.
Okay, okay. Okay, అయితే next week you will be doing your projects.
Yeah. Okay.
This week you will end up your this meets class sessions, and next week you have to do your project. It's like 7 to 10 days, I think, for project work.
Yeah, okay, ma'am.
It's a week, I think. We'll know you further. If there any change or if there anything, we'll let you know.
Ma'am, regarding the project, how do we submit our project to you?
All those stuff we'll let you know. So don't worry about those things. We'll support you.
Okay.
Yeah, we'll there for you.
Hello, ma'am. Hello, ma'am.
Hello,
Hello, ma'am.
hello, hello,
Ma'am.
hello.
Hello, ma'am.
Huh,
Hello.
hello.
Ma'am, how many members should be there in a group, ma'am?
You have to individually choose your project title. So,
Okay, ma'am.
yeah, it's your wish to do anything. So, your friends and you can choose the same thing, I
Okay,
think.
ma'am.
Yeah.
Ma'am, we are 4 members. Same same internship joined in this Blackbucks, ma'am. We can do same
Okay.
project, ma'am.
Yeah, your
Okay.
your friends and you can choose the same thing. Among the 20, you have to choose, right? It's an
Okay,
individual
ma'am.
decision to choose what what you want to do.
Okay. Hmm. Thank you, ma'am.
Okay, okay.
Ma'am, if the project submission is like through PPT, ma'am.
We'll let you know how to submit your project and things. Uh, Meanwhile, you go through the assessments and assignments this week. About the We'll let you know in the next session, next meet, or in the Telegram or something. We'll let you know about the projects and all.
Okay, ma'am.
Good evening, ma'am.
Good evening.
Madam, by the project is the hardware or software, like ma'am, we can do by hands or by using the Arduino software.
You
We
have
can work
to.
on it.
I think you have to buy your Arduino or Arduino and sensors and build it hardware. You have to
How
do
much the cost,
on
madam? Kit, all the Arduino
with
kit.
the cost of the Arduino kit.
Yes, madam. And the sensor, the
It based on your project, right? Just search it about that Arduino board and the sensors price. You
okay,
can get in the online, or you can go through the any hardware shop and you can get them.
okay, ma'am. Thank you, ma'am.
Okay. It's a recap class, right? Topic name. It's a recap session too. Actually, I don't know about the certificate and all those things. I don't know the the end date of this internship. Last date to select the 6th. It's 6th July. You can
Ma'am,
access your summaries and PPTs in the TapTap website. PPT of the session and summary of every session. You can access them in the taptap.blackbucks.me login website. You can go through them whenever you are free.
Ma'am,
Huh?
if we have any doubts regarding project, how can we contact you?
Uh, I think we'll keep some meets in the evenings about the projects.
Okay, ma'am.
Me and another one are there for the for your project uh, things to support you, to guide you about the projects. So individually we'll keep some Meet or some Google Meet or something regarding the projects. Okay, don't worry
Oh,
about them.
ma'am, can we get the list of project titles?
Yeah, the 20 lists are there in the website, right? You have to choose from them.
Okay, ma'am.
Okay. Actually, you can access your PPTs and summaries in TapTap website. I will show you how. Go to taptap.blackbucks.me login. Student, go to my college and college training. Search for ES and IoT. Short-term ES and IoT internship. Here you can get your PPT of every session 1 PPT and summary as well. And all those stuff you can access here. PPT and summary of every session, okay? I have posted the link, project titles link in the chat box. Go through the link and choose your project title. Every details are in the Telegram group. Please join in the Telegram group. You can get everything in there. Every small message you can get there. Please join in the Telegram group. There is a Telegram group named IITD-APSCHE Embedded Systems. Embedded System and IoT short-term internship. Please join in the Telegram group. You can access every message there.